Good morning. This is Stephen Smith. The date right now is 9/19/2019. It is about 9 o'clock in the morning. Last night, when I did the lecture, I see that I forgot to press the record button. Make sure that I have it pressed today. Okay, so I am recording now, and let's see, I have a microphone bouncing, so I'm up and running. I'm going to cover briefly what I covered last night so that I can get something up. I was talking about having about our tables. This is the way I recommend that you set your tables up, or you set your program up. I'm breaking up my SQL into various um, areas, and I'm numbering it 1, 2, 3, 4, 5 in the order that I'm going to execute it. The first thing that I'm going to do is I'm going to create the tables. So if I look at that, let me get to that spot. There we go. So creating the tables. And I'll run these guys in order of 1, 2, 3. So this guy drops the tables, and then it recreates all of the tables, drops the rounds, drops the games, drops the players. I have added one thing to it. I have added a P name, the player's name. So there's a player ID, which is your user ID, and a name. I just wanted to put something else in there it kind of throws a little monkey wrench into things. I'm not going to worry much about it. I'm not going to demand that I don't have a not null constraint on it or anything like that. It's not part of the primary key. The primary key is PID. P name is like Joe or Bob or Bill. PID would be whatever you want to use in the game. It could be an anonymous one. So I drop the games and I recreate the games. And I have some test data in there. The next one, look at, let's see, Control O for open, create the sequence. I'm going to just have one sequence. Now, in the past, I have had a whole bunch of sequences. I've had a sequence for the game ID, a sequence for the round ID, a sequence for this and for that and something else. I'm saying I don't really need that. It doesn't really matter. A sequence has up to 4 billion values in it. So I really don't, and I can make it long. If I make it a long end, I can be even bigger. So all I need is one of them, and I'll just select from that. Anytime I need a unique number, I'll just grab it from there. So I'll probably start with the game, and they'll go 1, 2, 3, 4, and then if I put in rounds, they'll go 5, 6, 7, 8. That's fine. It doesn't hurt anything. So I'll just drop the sequence, create the sequence. Oh, let's see. I had a whole bunch of them in there, so that's why it had to be its own. I had 5 or 6 sequences, but I really don't need them. Okay, next one is creating functions. Let's look at these functions. Let's see. I want to open one other file and show you a better function, I believe. So function demo. This particular function I wrote, it's a find winner. So this guy finds the winner because the winner of a game, whether it's a player 1, player 2, or a tie, is a function of the 2 input parameters. So this returns a char. My particular function checks and sees that if P1 and P2 are not in RP and S, and the idea being I think I need to check for null here because I'm not sure what would happen if I ask that about null. I really can't say is null in this set because logically in some databases null is a subset of every set. So sometimes that will come back true, sometimes false. So I just check, is it null? And then is it in this set RPS? If it is not, X is my error code. Else, if they're equal, it's a tie. Else, check any way that player 1 can be the winner, return 1. Else, I return 2. Now, these functions are a little bit odd. A function, remember, is something that takes 2 values and returns a value. So this takes 2 characters and returns a character. It can return anything that we know. It can return a string, a number, a date. In SQL Server, a function cannot return a row. It cannot return a record type. So it cannot return something that has 2 or 3 different components on it, I don't think, unless there's something hidden in here that I can't find. A function can return a table, and we'll touch on that briefly before we get out of here. So a function can return a table, and that's really gets real interesting. But this is kind of strange, because if you look at this, at the logic here, so if some condition, then return the x. Else, if some condition, return the t. Else, if some condition, return 1. Else, return 2. Folks, there is no way to get out of this if-then-else statement and not return something. Yet SQL Server makes your last statement be a return. So I put return null in there, and I'm saying this line is a bit odd because it cannot execute. You'll never get there. Nonetheless, if I don't have it there, it will throw an error. Another way I could get around it and not have it there is just have it drop through. In other words, if this, return x, else if this, return t, else if this, return 1, not have an else, and then just drop through and hit that return 2 at the end. I don't like either one of them, really. I guess I would do it this way. Given that I have to, I don't like it having this return. I personally like the purity of the logic that I have to hit something in here, a return, and I don't like that making me put this return null down here that's never going to execute. Anyway, this is how you would call it. You say select DBO winner, and you have to say DBO.fn winner, and then pass it 2 parameters. If I execute that, I guess I haven't created it yet. Execute. Okay. So let's see. Rock, paper. This should come back with a 2. So if I execute him, I should see a 2. I create a table here, put some plays in it, and this is how it's useful. Oops. Okay. Here is, I'm creating a view on plays. I have P1 and P2. In the view, select P1, P2, and DBO winner. So I have created a field in this table that is the winner. And I never have to insert it. I just say, if you say select everything from my plays, boom, I get the winner. So there it is right there, ties and 2 and 1, and at the last 2 are x and x because they're invalid. And that is how a function is used. It is much stronger to use in a table than a procedure. So a function will go into a table like this, not into the table per se, but it will go into a view which amounts to the same thing, because in this view, my plays, I can insert into it. I'm inserting into it right here, insert into my plays. So I'm inserting into the view, and then when I select from the view, I see the winners just dropping out for me, which is kind of nice. Save that. Okay, I believe I sent you that in the zipped files. Create the function. Let's see, a couple of functions here. I would create a okay, here's a function called getPlayerName. We're going to use that one later. So this function takes a player ID and gets the player name. Okay. So it takes a player ID. And let's see, I use these parentheses. I believe that these parentheses are optional. but I always use them anyway, this pair right here around the parameter list, and it returns a player name. So it takes the player ID, gets me back the player name. Basically, all it does is go in and select player name, the ID, returns that player name. So it has a local variable. Then I go in and select that local variable out of T players and return it. Fairly simple. Here is another one that's going to be real interesting. Let's see. I'm going to come back to this one in just a second. I'm going to open another one. I'm going to open the create procedures. Okay, here's a handy little procedure that we would have. This is a procedure called PROC swap ID. And if I pass it two PIDs, P1 ID, P2 ID, and I'm sure these parentheses are optional. I don't know whether they're optional on a function or not. I generally use them because most languages use them. We begin, I declare a local variable. There's a place to hold it. Put P1 ID in the local variable. P1 ID gets P2 ID, P2 ID gets the local variable. So basically it just gets exchanged. This is used in just about every kind of coding you can do. It's straight out of Computer Science 101. And so if you took any kind of programming class, you've probably written that procedure. What's this? And then insert the player. It was brought up last time that the procedure insert player can proceed using if then else logic, or it can proceed using the try catch. This particular one does a try catch. Now the thing I like about try catch is I pass it the PID, I pass it the P name, and I pass it the error level as the output parameter. Now, this try catch has an error message, which is kind of nice since that error message comes back from the exception handling. So this message comes back and tells us what happened. I default this guy to null because you don't have to have him. If you call it without error message, it's fine. It just defaults to null. And then I try. So I try to insert. And if I fail, I catch, and then I just send you back the error number and the error message. So I had to test it, and what I did, I set this guy up and I printed the error message, printed out, and I gave it a duplicate primary key, and I got back the error message 2726, and then I put in a null primary key and the error message 515. And let's see, this one right here, if I will start and run these, execute, everything's fine. And let's try inserting a null. Insert the null, and oops, I forgot to print. Be nice if I execute that line where I print. Execute, and notice that I print the 515 because I'm trying to put in a null primary key. And if I were to try to if I put in the primary key and then tried to put it in again, I would get error message 2726. Okay. And then inserting the game. Inserting the game is fairly easy. I'm just using straight ladder logic here. I'm going to go back to the functions. I don't know why I have them ahead of that. So in my creator alter function get game ID, basically I have to give it two player IDs, P1 ID, P2 ID, and I want it to return to me the get game, the game ID. And this is going to come in handy when I start to put a round into the table. So if I go get the game ID, I don't know whether they are coming to me in the correct order or not. But I know that in the table, player 1 must be less than player 2. Player 1 must be less than player 2. The table is going to enforce that. Everything's going to enforce that. So I'm going to double check that. And I check, is player 1 greater than player 2? If it is, I got a problem. Now, I would really like to use that procedure swap ID that I just wrote in that other file over there. Unfortunately, a function will not allow me to call the procedure. TSQL won't let you call procedures in functions. Okay, I don't like some things about TSQL, and this is one of them. So I just have to write it again. If P1 ID is greater than P2 ID, basically there's the code. It's just straight out of the procedure, and I just swap them. It'd be a lot easier just to call the procedure, but hey, if it won't let me, it won't let me. So if they're backwards, make them right. Then go to T Games, select Game ID, where P1 ID equals P1 ID in the table, P2 ID equals P2 in the table, and return the game ID. If it's not in the table, it returns a null. And we can run some test code. Phi and Phi, I believe, is going to be game ID 1. Let's execute that. Something was, oh, okay, I got to run these things on this computer. Execute, come on, there we go. Now I can run them. Execute. Game ID is, okay, well, it's not 1 because I've been playing around with this and I've been doing some inserting. So the game ID for Phi and Phi is 113. I guess the game ID for this one will be 114. Yeah, 114. And I don't have a game between Phi and Pho. So when I try to select that one, I'm going to come back with null, I believe. Yes, I did. And now I can take a look at games and see if that was correct. So you see 113, 114. That's because I've been running this a few times and I have not reset that sequence. So as I run and as I go, that sequence will never reset until I go in, drop it, and recreate it. Then it'll start back with 1 again. It doesn't hurt anything. I don't really care what the numbers are. Okay. I keep wanting to say, are there any questions? Don't have any audience today. Okay. Well, my next topic is, so functions, create the procedures. I'm going to drop down to creating views. And we talked about, in class, we talked about when I do reports, what is a report on the database? Well, a report on the database is just the SQL that gives me the data that I want. And usually I will create this into a view. All I do when I create a view, I say create view, I give it a name as, and then I give it an SQL statement. So the SQL creates this thing that acts like a table in my database. It's not a table, but I can select from it. I can insert into it under some conditions. I can delete from it under some conditions. I can create a view based on a join. I can create a view on about anything. And if it has a join, it's very difficult to insert and delete from it. Sometimes you can. I will leave that for your reading to decide when you can. If you can, you can. If you can't, you can't, is what it kind of comes down to. If it would create any ambiguity. If it's based on a single table and you have everything that is required in it, then you can insert into it. And if you have, again, you could delete from it if you don't break any other rules. So a view is kind of handy, and you set up the views just like you would. So I build the SQL statement, and then I create the view out of them. So first thing, my first task for reporting, if I were creating a view, would be find the players that are not involved in any game. Find the players not involved in any game. Well, this is pretty straightforward. This is just a childless parent query. You point the outer join at players, and that's about it. It's got this or in it, so the on condition there has an or because you have two foreign keys, so you have to check them both. Now we could write it as a union. There's other ways to write this. I'll leave it to you to show that these two guys are the same. Whether you do it this way, it amounts to exactly the same thing. Anytime that you're working with pure SQL, it really doesn't matter most of the time how you write something, for the most part, because the system will take the runtime optimizer will come in and it will just change your query all around. So you don't need to worry about which one is more efficient. They are both equally efficient because you don't know what you're going to get when you know you're going to get the answer. So I believe this is going to give me one player. Well, it would help if I would say which database to use. Okay. If these were run as a script, you wouldn't have to do that. But since okay, so execute, and I get one player, Boz, and the player's name is Ed. Notice I can take the PID, P name, and all that stuff. No problem. Everything's coming from one table, and it's outer joined with the games. But all the output comes from one table because I only want it where the game is null. I'm not looking for games. I'm looking for no games. And I'll leave it to you to decide that this one does the same thing. Task 2, find all games with no rounds. Again, simple childless parent, outer join, pointed at the games table. And here we go. I should have one in there. Boom. Have one, game number 116. It has it is a play between PID FUM and PID Quux, whoever they are. And whoever they are is kind of important. Now, here's the question. Who are they? Okay, this is why I put the player name in there, John or Bill or Bob, whatever his name is, her name is. That is, it's simple so long as all of the output comes from the games table. So everything here is coming from games. I take games, left join it to rounds. That's a piece of cake. Add the players' names to number 2. Now he turns into a bucket of worms, I believe I say there, because now I have something coming from another table. I'm going to have to put the players table in there. Not only will I have to put the players table in the join, I'm going to have to put the players table in the join twice because I have 2 foreign keys pointing into the players table from games. That really throws a hitch into our get along right there. Okay, remember that function we wrote where we need the function. Remember this function. Now it's up there in create functions also. I just reproduced it here. Creator alter function get name, get game ID, excuse me. Get game ID, it takes 2 player oh, okay. I'm sorry. We'll do get game ID in a minute. Get name. It takes a player ID, returns the name. Okay. So there's a boom, gives me back the name. I can only get away with this if P name is a function of PID. Well, it's a function. Yeah. I mean, this will work just fine. And it goes in there, and it's just a simple select statement, and it returns the P name. So now the task just became much easier, and I say put a line in there. Don't believe me, you try it without the function, and I'll leave that to you. So all I have to do is select the game ID, P1 ID, and then use the function to come back with the player's name using P1 ID. P2 ID, function comes back, piece of cake, execute, and there it is. Oh, that was Dale and Fred. I know those guys. Okay, why was this not a bad idea? Because anytime that function call is on the select line, function call on the select line is probably the best place to have one. Now, in the discussion down here, I'm pointing out that many SQL programmers do not like these user-defined functions. They say they are inefficient, and they definitely can be. This particular one is on the select line. Since it's on the select line, it will get called exactly twice. Remember, all the rest of this table joining business happens down here before the select line happens. So the select line happens, we've already resolved everything about that. All we need to do is go figure out what the name is. And that's just a simple single table query. So even though it's a function, yeah, it's a whole lot better than having the other table in the join. It only executes once for each row returned. So I don't know how many rows. Well, we're only going to return one row there. So the function will execute twice on each row, but it only returns one row in this case. It might return others. Just because this one happens to be one doesn't limit it to one. It could be a million. But for each row, the function is only going to execute, well, it executes twice, but I know how many times it'll execute. It's a simple linear function. Task 4. Retrieve one row for each round showing all information. Player IDs, names, game ID, round ID, player's token, and winner. Only show records that participate fully in both relationships. And I give you the hint there that whenever you hear that, you're looking for an inner join. Okay. Now, I put this one in there to be difficult. Let's see. I'm going to develop this one in steps. I have these two functions. I have a function called getGameID. We talked about that. GetGameID is pretty simple. It takes two PIDs, then returns the game ID. Now we're going to need that getGameID when we start to insert a round, because remember, a round, the primary key of the round ID is the primary key. The foreign key in rounds is the game ID. It is not the players. The players are not in the rounds table. All I have in the rounds table is the game ID. So I need to take the two players. It's a little bit like what I used in my example. Excuse me. My example was you walk up to to fill up on gasoline, and the clerk asks you, "What pump are you on?" Well, I don't have any idea what pump I'm on. I didn't look. Or you call up some help desk and they say, "Well, what is your account number?" I don't know my account number. I call up, I don't know, Frontier or Spectrum. They want my account number. Well, I'm calling you because my internet's not working. How do I get my account number? I don't know. But I do know my name. So I know the players will know their PID, but they won't know the game ID, but they have to have the game ID to insert a round. Okay, so that's why we have to have that function. We're going to have it later, but it's going to come in handy here. I have a function that receives two tokens and returns the winner. Yeah, that's real handy too, because we'll use that. Develop this one in some steps. So my first one, I'm going to select 5 tuples, meaning a row with 5 values on it. That's going to have a lot more before I'm done. So I want player IDs, game IDs, so the player's stuff, and I want the players' names. So PX is player's 1 ID, NX is the name. Okay, here's where we get nasty. Select P1, PID as, I'm calling that PX, because that's the ID. P1 name, NX. P2, he's Y. He's Y. I just gave him short names because I don't want to get real long. Then I call to get the game ID. This one isn't bad. Remember, a function call on the select line runs once for each row returned. Okay, I can take that cost. That's a cost that's livable. But from player one, from the join, now notice I'm using the old syntax here of the cross join, and where the join condition goes down here in the where clause. You could write it either way. Now here's the real rub right there. Notice that the function get game ID is called in the validation line where where we're deciding what rows to pass up. Now this guy is a cross product. This guy is going to run however many players I've got squared. So this one is going to get expensive. I don't want to have that function down there in the where line. And it's very, very bad to have it there because this one cannot be optimized. So that function is going to cost us big time in the validation line or in the join line. So this is the join condition. Don't worry about this P1 ID less than P2 ID. That's just weeding out some duplicates. But this guy is going to cost. Don't do this, I say. Let's see, don't do this either. This is just the same thing written in the newer syntax where I still have the function called in the validation line. And that causes me to notice I wrote this up here with the, this is the old cross join syntax. And this one says inner join. It turns into exactly the same thing. The code's not different. Okay, and then there's some discussion here. And I give you this code. This code was sent out and attached to the announcement. We don't want that. We don't want the function in the where in the validation line. Okay, here we go. Call the same stuff. I still have the inner join, but notice the on. The on, I'm saying on, and there what I would like to write is something like this. On P1 PID, comma, P2 PID in, select P1 PID, P1 ID, P2 ID from games. That would be nice. And in fact, in Oracle and many databases, I can write it this way. SQL Server says I can't. So I have to do a trick. And what I do is I take P1 PID, the two parameters, and I concatenate them into one string. And then I select a string of concatenated P1 PID, and I ask, is this string in that subquery? It's much more efficient than a function. And so what I get is when I run this, I get P1 ID, P1 names, P2 ID, P2 names associated with their various game IDs. Okay. Once I get this part done, it gets fairly easy. Basically, I'm just going to add in now. I'm going to turn it into a derived table, I think. Excuse me. I make it a derived table. So here is the query. And essentially, I call it D. You could have made a view out of this and then put the view into the next SQL statement. There's lots of ways you can do it. I'm not going to tell you how to do the programming. I'm just going to try to sketch the logic for you. So this is really what's driving that task 4. I'm going to add in the games and the rounds now. So inner join games, I just say join, and you can too. You don't have to say inner join in this class. If you want to say join and left join and right join, I guess you can. I'd say sometimes I'll just say join. Inner join games, and this one's pretty straightforward. That's just the foreign key of the D table. That's this table right here. He's got a foreign key. Well, he's got GID in him right here. So that's just a straight foreign key followed to a primary key, another straight foreign key followed to a primary key, and bingo, I'm ready to go. And now when I execute this, I see all of my data. And now I'm ready to create a view out of that. So every time I want to run this report for my management, I just go to that view, select everything, copy, paste it. And you know what I do with it when I do a report? I take it over to Excel, drop it into Excel and format it. I don't use very many report generators. I find them to be a bigger waste of time. I can format the report. I ask, who am I formatting it for? How do they like it? Because everybody wants it in a different way. So I find Excel is usually the best. And then I just save a template for that particular person. I think Excel is the better reporting tool of anything, even though it is just a spreadsheet. Okay, I'm being called out for right now, so I'm going to go ahead and pause the recording. Okay, I'm back. And that in a nutshell was what we did last night. Let's see, was there anything else? I talked a little bit and introduced the idea of where we're going next. And that was in the idea of triggers. And a trigger is essentially, it's a function that executes when you do something to the table. Excuse me. A trigger executes when you do something that changes data, changes the table. So a trigger would execute when you insert data, when you delete data, when you update data, but a trigger won't insert on a select statement. I can set a trigger to execute on anything if you change anything about the database too. So I can stop you, I can block you altogether from doing it, or I can say do something else. So this one, create trigger. The name of the trigger is check insert on TPlayers, and it executes instead of inserting into the table. I want you to abort that and do this instead. Okay, so then this is going to check everything again, and if everything is okay, then it's going to go ahead and insert it at the end. So it's going to run after the procedure. So the procedure runs, the procedure checks it first. Then the trigger runs, and the trigger checks it second. Now the trigger is going to be at a lower level. So if something bad happens in the procedure, if I get bad data into the procedure, well, that's just par for the course. The procedure is supposed to check the data. The procedure is not supposed to let anything through that's bad. If something gets through that is bad, now I have an escalating level of threat. So if something happens in this trigger, so I'm checking the insert, and this trigger finds something wrong, I'm going to be far worse about it than I'm going to react a lot worse than just simply returning an error code. I'm going to be much more proactive here in the trigger, because the trigger is getting down towards my last level of defense. We're going to put a couple in front of the procedure. We're going to have a layer of defense in the web page itself, but the trigger is the last thing that happens before I get to the actual table. So if something gets to this trigger and is wrong, I'm never supposed to, this is never supposed to happen. And then, an event that just happened, an event just happened that never should have happened. So it's time to take some rather drastic action here. Basically, I'm just throwing an exception, throwing a database error, primary key violation, and let's see, multi-row inserts I'm not too concerned with. This is a lower level one. But if this one ever happens, if we get here and have a primary key violation, because we're supposed to have already checked that, how did we get through that that table, insert player, with a bad primary key? We were never supposed to get here. So we want to, this one right now, we're just about to do the insert. And we don't want to try to insert. We don't want to ever hit the table constraint. So the table constraint is in fact, our last line of defense. The trigger is just before it. So at the trigger level, what I would do, I would take some drastic action. And we're going to be talking about that later. So we're gonna be spending a good bit of time on triggers. Let's see. I gave you in the handout or in the zip files that I passed out. I gave you the Word document that says, what I want as part one. So we're pretty much ready to do part one. Part one will not include triggers, or you may if you want to, but you don't need to. Okay, I'm gonna go ahead and end there. Stopping the recording.